let's say we've got a rectangle. Draw the rectangle. There's the rectangle. And we have two diagonals across the rectangle. That's one of them. And then we have the other diagonal. And this rectangle has a height of h. So that distance right there is h. And it has a width of w. It has a width of w. What we're going to show in this video is that all of these four triangles have the same area. Now, right when you look at it, it might be reasonably obvious that this bottom triangle right here, will have the same area as the top triangle, as this top kind of upside down triangle. That these two have the same area. That might be reasonably obvious. They have the same dimension for their base, this width, and they have the same height, because this distance right here is exactly half of the height of the rectangle. They are symmetric. They are equal triangles. They have the same proportions. Now, it's probably equally obvious that this triangle on the left, has the same area as this triangle on the right here. That's probably equally obvious. What is not obvious is that these orange triangles have the same area as these green-blue triangles. And that's what we're going to show right here. So all we have to do is really calculate the areas of the different triangles. So let's do the orange triangles first. And before doing that, let's just remind ourselves what the area of a triangle is. Area of a triangle is equal to 1/2 times the base of the triangle times the height of the triangle. That's just basic geometry. Now, with that said, let's figure out the area of the orange triangle. The area of the orange triangle. It's going to be 1/2 times the base. So the base of the orange triangle is this distance right here. It is w. It is w. So 1/2 times w. I'll do that in 1/2 times w. I want to do that in a different color, in the color I wrote the w in. 1/2 times w. Now, what's the height here? What's this height? What's this distance? Well, we already talked about it. It's exactly halfway up the height of the rectangle. It's exactly, so times 1/2 times the height of the rectangle. Times 1/2 times the height of the rectangle. So what's that going to be? You have 1/2 times 1/2 is 1/4 times width times height. So 1/4 width times height. So the area of that triangle is 1/4 width height. So is that one. Same exact argument. They have equal area. Now, what's the area of these green or these green-blue triangles? Well, once again, area. I'm going to do this in a green color. Do this in the area is equal to 1/2 base. So these guys are turned on their side. The best base I can think of is this distance right here, that distance right there. Or if you look at this triangle, it's this distance right here. It is the height of the rectangle. So now we are dealing with the base, in this case, is the height of the rectangle. Don't want you to get too confused. The height is now going to be what? The height of this triangle. So these triangles are turned on the side. So what is this distance right here? What is this distance? Well, it is exactly half of the width, right? We're going exactly half of this distance right here. This point right here is exactly halfway between these two sides and halfway between those two sides. So this distance right here is 1/2 the width. Or the height of these sideways triangles are 1/2 of the width. So the height here is 1/2 of the width. Little confusing. The base is equal to the height of the rectangle. The height is equal to 1/2 of the width. But if you do the math here, the area is equal to 1/2 times 1/2, which is 1/4, height times width. Or you could just write that as 1/4 width times height, which is the exact same area. So the area here is 1/4 width times height. Area here is 1/4 width times height, which is the exact same area as each of these orange triangles. And it makes sense because each of them are exactly 1/4 the area of the rectangle. Hopefully you enjoyed that.